Today we'll first discuss how to find the molecular mass. The same thing you did the last time, and then learn the definition of atomic mass or molecular mass. First, start with the definition. This definition is a theoretical definition. Practically, it's not the way the mass is calculated. Atomic mass or also known as relative atomic mass. When we say relative, the term relative is when we compare one thing with another, we call that as relative atomic mass. Basically, the concept is that as you know, if I write carbon, so carbon is 6, atomic number is 6 and atomic mass is 12. If I divide this carbon into 12 parts, so example, we have a carbon, atomic number of a carbon is 6 and atomic mass of carbon is 12. And we divide this carbon into 12 parts. So what will be the mass of each part? The mass of each part will be 1. Because the mass of carbon is 12. So if you have a carbon which is having a mass of 12 and you divide into 12 parts, then what will be the mass for each part? The mass of one part will be 1. So what is the definition of atomic mass? It's a theoretical definition. So it is mass of element compared with 12th part of carbon. What does it mean, mass of element compared with the 12th part of a carbon? Like example, if you have a balance, you have a beam balance and on your left hand side you have an unknown element. You don't know the element mass, so that's an unknown element. So say X, any unknown element is there. On your right hand side, you want to find the mass of this unknown element. So how you can find the mass of this unknown element? So you will, how to find them? This is a theoretical way. Practically, it is not done by this method. Practically, there is a device which is called a mass spectrometer used to find the atomic mass. This is a theoretical definition, only just a theory, that if I want to find the mass of any substance, so if I divide first carbon into 12 equal parts, so when I divide the carbon into 12 equal parts, the mass of each unit or mass of each part is 1. The mass of each part of carbon is equals to 1. So example, 3 units of carbon are balancing this. Or say 4 units of carbon are balancing this unknown element X. So what is the mass of this element X? If 4 units of a carbon are balancing this, so what is the mass of this element? The mass of this element is equals to 4. So this is just a theoretical definition. Why specifically they took carbon? Because it was believed that most of the compounds contain carbon, so carbon is the most important element. But later they found it's not necessary that all compounds should have a carbon, but it was believed initially, like in the early century, 19th century, this was the concept that most of the substances are made up of carbon. So that's why they took carbon as a basic unit. But later they found it's not necessary that all the substance should have carbon. There are different elements may present in the different substance. So maybe carbon is absent. So this again, I repeat, this is a theoretical definition. It's just a theory which explain how you find the atomic mass. So it states it is a mass of element compared with the 12th part of carbon 12. So when I compare the mass of an element with 12th part of carbon 12, then we call that a relative atomic mass. Not atomic mass, relative. Why relative? Because it's a comparison. Compared to carbon, what is the mass of a substance? That's why specifically we call relative atomic mass, or I can say A, capital A, R. R is for relative and A is for atomic mass. So if we represent the atomic mass, relative atomic mass, AR is equals to 4. Is it clear? The concept of relative atomic mass? Any doubt in this? Any doubt? If you have any question, you can use a chat.
No, sir.
Okay. You can use the chat or you can use your mic to convey. Same way, relative molecular mass. So what is relative molecular mass? It is denoted by M and subscript R. R is for relative and M is for molecular mass. So it is molecules means group of atom. So it is mass of molecule compared with 12th part of carbon. So when we compare the molecule, first the definition of atomic mass, it's mass of element which was compared, or mass of, because it's the term atom, you can also write here specifically atomic, or it is a mass of atom compared with the 12th part of a carbon. Instead of writing element, you can, if molecular mass is there, it's a mass of molecule compared with the 12th part of carbon. So example, you have a molecule. Again, this is not a practical way of finding the mass, it's just a theory. So example, you have a molecule. Molecule means group of atom is called molecule or known as molecule. So this is a molecule and you want to find the mass of this molecule. So again, you will use a balance. And here you substitute the molecule, and on the right hand side example, you use unit of the carbon and 5 unit of the carbon are balancing this molecule. So 5 unit of a carbon are balancing this molecule. What is the relative molecular mass? So relative molecular mass is equals to 5. Is it clear? Because the mass of each unit of carbon is 1. Because what we did, we divide the carbon into 12 equal parts. So when we divide the carbon into 12 equal parts, mass of one part is equals to 1. And we place this molecule in on a balance, like a beam balance, and then we place the part of the carbon. And when we place a part of a carbon, how many parts of a carbon are balancing with this molecule? we simply call that as relative molecular mass. Why the term relative is used? Because it's a mass of a molecule compared with a carbon 12. So whenever you relate something, you compare something, you call that as relative molecular mass. For a molecule, relative molecular mass. For an atom, relative atomic mass. Anyone having a doubt? Yes.
We should compare them always to carbon.
Yeah, this is just a theory. This practically it's not done, but this is a theory. And why this theory? They put forward this theory because it was believed in early 19th century that most of the substances, if not even most, they assume that almost all of the substances contain carbon. That's why they make carbon as a base unit.
Okay.
But later they found that it's not true, that every substance does not have a carbon. There are different substances, means there are substances which have different elements, or carbon is not present in that. But it was because the early 19th century this concept was there, so they continue and explain the idea of relative atomic mass with carbon only, not any other element. So this is a fixed definition which you have to learn, and you can understand the concept as well, but this is not used practically. It's not used the way it is written, like it is a mass of molecule, like you put a molecule on a balance and you put carbon on the other pan and compare. It's not done like this. Practically, there is a device called a mass spectrometer, which is used to find the mass of element or molecule, mass of atom or molecule. But this is just a theory which explains a theoretical definition how we can find the atomic or molecular mass. Is it clear?
Sir?
Yes.
Sir, in the periodic table then,
Yeah.
like all of the numbers that are shown, they are relative atomic masses?
Yeah, they are relative atomic masses.
Like for example, magnesium has a relative atomic mass of 24. So that means
24 parts of carbon will balance magnesium.
Okay, sir. Thank you.
Anyone else having a doubt? If you don't have doubt, you can also convey like no doubt. So I will move on. And if anyone want to take a screenshot, can take now. So I will move on.
Sir?
Yes.
Sir, like chlorine, it has 35.5.
So what does it mean? It means 35 full parts and then half part. Like 35 full units will be there. Each unit is one. So 35 full unit is there and one will be half. So 35.5 units of carbon will balance with. If it's decimal or a fraction, then that number of carbon will be used. The example, because when we divide into 12 equal parts, each unit is 1. If I divide this unit into further half, so each unit will be 0.5.
Okay, sir, I get it. Thank you.
Then diffusion. Diffusion, it is movement of the molecules from region of higher concentration to region of lower concentration. So when the molecules actually move from region of higher concentration to a region of lower concentration, we call this process as diffusion. So example, if you have a container which is filled with, say, vapors of alcohol, So because there are more particles in this region, concentration means number of particles present in a unit volume. When we say use the term concentration, it means number of the particles present in a specific volume. So example, you have a container which is filled with, say, alcohol or any substance which can easily vaporize. So this is a region where you have more particle. Outside you don't have particles, so this region is called a higher concentration. Concentration in short, I'm writing CONC. The other side, like the outside, you don't have any particles. So if you don't have particle, it means that part is refers to low concentration. So if I open one side of this container, so what I will observe that these particles which are already moving randomly, they will move from a region or a space of a higher concentration to a space where they have low concentration. And this process of movement from higher concentration to lower concentration is refers to diffusion. So movement of molecule from a place where they are more to a place where they are less, this process is simply termed as diffusion. And this diffusion depends on number one, it depends on state, like whether it's solid does not have, there's no diffusion in solid. Liquid and gases diffusion can occur. It depends on the state of substance. It depends on molecular mass of the molecule. And it also depends on temperature of the container or temperature of the surrounding. Higher temperature. So state of the substance, diffusion depends on what is the state of a substance. Number one, like the state, if you have state, solid does not diffuse, so you are having two options only, two choices. Either it can be a liquid or it can be a gas. Which one you think will diffuse faster?
Gas.
Gases will diffuse faster because the particles are far away from each other, weak force of attraction. So rate of diffusion in gases is much faster as compared to that in liquids. Liquids also diffusion occur, but relatively slower as compared to that of gas. Number two, it depends on the mass of the molecule. For mass of the molecule, you have to use the periodic table. Like example, if I'm comparing two substances, one is carbon dioxide, another one is NH3, ammonia. So CO2, carbon dioxide, NH3 is ammonia. So for this, what I have to do, I have to check their masses, for molecular mass. So when I check carbon dioxide, I will check the mass of the carbon. So carbon position is here and the mass of carbon is 12. Oxygen is 16, nitrogen is 14, and hydrogen is 1. So carbon 12, nitrogen 14, oxygen 16, hydrogen is 1. So when I find the mass, molecular mass, carbon is 12 plus oxygen is 16 times 2. So that is equals to 32. So 32 plus 12, which is make 44. So total mass is 44 for carbon dioxide. What about NH3 or ammonia. Nitrogen is 14 plus hydrogen is 1 multiplied by 3. So it will be 14 plus 3, which is equals to 17. So which one you think diffuse faster? The lighter gases, the lighter molecules move faster. So in this example, which will diffuse faster, NH3 or CO2?
Carbon
NH3.
dioxide.
Which will diffuse faster, lighter molecule, the one which is having a less mass? Heavy molecule,
NH3.
NH3. Because NH3 is having a mass of 17, whereas CO2 is having a mass of 44. So NH3 will diffuse much faster as compared to carbon dioxide. And it also depends on the temperature. Like if I say this container at one day, like day one, this container was at a temperature of 20. And day two, this temperature, the container was at temperature of 25, having the same amount of molecule. Which condition diffusion will occur at a faster rate, A or B? Day one temperature is, day one, yeah, temperature is 20, day two temperature is 25. So at 25, because of higher temperature means particles have more energy. If the particles have more energy, they will diffuse much faster. Same way, is it clear? The concept of diffusion. So diffusion is a movement from region of higher concentration to region of lower concentration, and it depends on the state of the substance, mass of the molecule, and temperature. So temperature, higher temperature, rate of diffusion is faster.
Sir,
Yes.
but doesn't it depend like on surface area and other things?
Surface area when number of the molecules exposed to the surrounding, that you mean?
Yes.
But for liquid and gases, it's not that. I think you're mixing the concept of evaporation. Evaporation, because for gas, you cannot define a specific surface area for gas. And for liquids, there is a surface area, but that will affect the evaporation, not diffusion. So you don't have to consider the surface area.
Okay.
The three factors: mass of molecule, state of the substance, and temperature will affect the rate of diffusion. I'll give more examples. Anyone want to take the screenshot can take now. Then example, diffusion and chemical reaction. The term chemical reaction refers to when there's a change in the atom, structure of the atom, arrangement of the atom. We call that as a chemical reaction. So if you have a container, you have a tube, a cylindrical tube. One side of this tube, you have NH3, ammonia. The other side of the tube, you have HCl. Both are gases. Hydrochloric gas. This one is gas. This one is also gas. And you want to identify which position they will react. You have options A, B, C is the center, and D. So if a question is which position, NH3 and HCl will react. So how you'll identify which position they will react, A, B, C or D? C is exactly the center of the tube. So how to identify this? First, you have to find the mass of each. And you have to compare the rate of diffusion, like which diffuse faster and which one diffuse slower. So when we find the mass of each, if I find the mass of NH3, in case of NH3, nitrogen is 14, they use a periodic table, and hydrogen is 1 multiplied by 3. So the total is 17. HCl, hydrogen is 1. Chlorine mass, when you check the periodic table, is 35.5. So 1 plus 35.5, 36.5. So first thing, you will identify which will diffuse faster.
NH3.
So NH3 will diffuse faster. So because NH3 is lighter, so it will diffuse faster. And when it will diffuse faster, it will cover greater distance. So if, for example, if they react at the center, if the reaction occur at the center, what does it mean? It means that both gases has the same rate of diffusion or same speed of diffusion. But in this example, when we work out the mass, NH3 is diffusing faster than HCl. So NH3 should cover greater distance. NH3 should cover greater distance as compared to HCl. So which point they will diffuse? They will diffuse, which point they will react? They will react at point D. Is it clear why D? Because NH3 is diffusing faster. So NH3, as it diffuses faster, it will cover greater distance. Where HCl, it's taking more, it's heavy, so it is taking more time to diffuse. So which position they will react? They will react at position D. Why not A or B? If I select A or B, it means HCl diffuse faster, which is wrong here. NH3 is diffusing faster because NH3 is diffusing faster.
Because it has a lighter molecule.
Yeah, it's a lighter molecule or having a lower mass. That's why it has a faster rate of diffusion. Is it clear, this example?
Yes, sir.
Okay. Now I'm giving you another question. You have to solve this question and send your answer on the group. You can take the screenshot first if you want to, and then I'll erase. The same question. Lighter gases diffuse faster. So that's why if a gas diffuse faster, it will cover greater distance. So this side you have a gas which is CH3 NH2. And the other side you have a gas which is CH3 Cl. And the mass, I'm telling the mass for each, mass of each element. You can use a periodic table, but I'm telling the mass. Carbon is 12, hydrogen is 1, nitrogen is 14. And chlorine is 35.5. The question is identify which position These two gases, now NH3 is not there. The gases are CH3, CH3Cl, so which will diffuse faster, in which position CH3NH2 and CH3Cl will react. Send your answers on the group. When you find the mass for this, carbon is 12. When you move to different atom, then just put a addition plus sign. Then hydrogen is 1, and how many are there? 3, plus chlorine is only, if 1 is there, then only just write the mass 35.5. So 12 plus 3 plus 35.5. So 12 plus 3 is 15. 15 plus 35.5, which will make 50.5. So 50.5 is for CH3Cl and 31 is for NH3, CH3NH2. So which will diffuse faster here?
CH3.
Yeah,
CH3 and H.
NH2,
NH2.
CH3NH2 will diffuse faster. So if it diffuse faster, which point it will react, likely to react? It will react at point, because it will react at center if both have the same masses. If two gases have the same mass, then they will react at the same point, means at the center. But if one of the gas is diffusing faster than the other, so the one which diffuse faster will cover greater distance. So as it covers greater distance, then the point at which they react is not same distance from both ends. Less than a minute left. I will share another link and we'll do some questions related to this topic. I will share this new link with you, and then we'll discuss some questions related to the topic.